So we can specify a random number, and we don't have to. If we don't, then it will pick something automatically, but we can specify a random number. So in this case, I'm just specifying the number 42. And what this will do is this will initialize a random number generator, and then using that random number generator, certain rows will be picked. So a certain fraction of 20% fraction of the data will be put into test df, and the remaining will be put into what I'm calling train val df. Okay. Now the benefit of random state is that it gives you the guarantee that every time you pass 42 as the random state, the same fraction, the same 20% fraction will get picked as the test set. So the benefit here is that each time you rerun the notebook, your test and validation sets will not change. So we want a random fraction, which is picked randomly once, but we also want it to be fixed across our runs, because otherwise we will not be able to compare with each run of our notebook whether we're doing better or not, right? So you want to pick a random fraction, but we want to fix it, and that's what random state is for. Okay, so now we've created a test data frame, which is 20% of data, and then we have a training validation data frame, which is the 80% of the data. Now out of the 80, I once again want to do a 20-60 split, which means 25% of the remaining data becomes validation data, and then 20%, 80%, 75% of the remaining data becomes the training data. So I'm using train test split once again, and this time I'm setting the test set to 0.25, and I can use a different random state, but if I want, but it's okay. I'm just using 42 again here, and that's going to give me a training data frame and a validation data frame. So first we extracted a test data frame, then we extracted a validation data frame, and finally we were left with the training data frame. So this is how we have created 3 data frames, and you can check their sizes. Training data frame now contains 84,500 data points. Validation data frame contains 28,000. Test contains 28,000. Okay. So this is what you will do for most data sets. You will pick a random sample as a validation set and a random sample as a test set. If you're given a test set already, this will go away. Maybe you'll have a separate CSV file for test. So you'll simply do a 75-25 split between training and validation. Okay. Now, one other thing I want to add here is when you're working with dates, which we are in this case, fortunately or unfortunately. So when you're working with dates, there is an additional consideration to keep in mind, because we want to take this model which has been trained on historical data, and then we want to use it in the future. Okay. So that means that your model ideally, when it is making prediction on a certain date, it should not have seen any data that came after that date, right? Because you should not train your model to learn from future data to predict past data. So whenever you're working with, this is called time series data, or whenever you're working with dates, it is often a better idea to separate training, validation, and test sets with time. So what you want to do is, maybe if we just check out the years in the data. So we have, this is what the distribution of the data looks like. We have these many, we have a bunch of values for 2007, a bunch of them for 2008, 9, 10, 11, 12, 13, 14. And we are presumably going to use the model to make predictions in 2018 or 2019. So here is a good way to divide the training and validation and test sets. How about we take the data till 2014 as the training set. So we train the model using data till 2014. Then we use the data from 2015 as the validation set. So now the model will be evaluated on data from the future, data it has not already seen in the past, right? So we use 2015 as the validation set, and then we use 2016 and 2017 as the test set. So our final accuracy of the model will be reported by its performance on 2016 and 2017, while the model has been trained and evaluated on data till 2014 and 2015. The benefit of this is that because we are going to use the model in 2018 and 2019, so the test sets score is going to very well reflect how the model will perform in real life. On the other hand, let's say if you pick 2011 as the test set, then it's possible that the model may use some information from 2010 and 2012 to become a better predictor for 2011 than it would be for 2018, right? Because it has access to data from the past as well as the future. So what I want you to take away from this is, whenever you're working with dates or with time series data, it's often a good idea to take the last fraction as the test set, and maybe a fraction just before that as the validation set. Okay. So that's what I'm going to do. I have created this year column. So I'm going to convert raw df.date to a date time series, and then I'm going to get the year out of it. And for the training data frame, so I'm going to ignore what I had created earlier, all of these data frames using random splitting. But for the training data frame, I'm just going to use the data before 2015. For the validation data frame, I'm going to use data just from 2015. And from the test data frame, I'm going to use the data after 2015. So 2016 and 17 are going to be the test set, validation is going to be 2015, and training is going to be before 2015. And this is what the split looks like. So it's not a perfect 60-20-20 split, but we have still ensured that the test validation, that the validation and test set both contain data for at least 12 months or an entire calendar year, which means they see all the seasonality and they occur in the future after the training data. So which will more accurately reflect our model's performance in the real world. So the whole purpose of test, training, validation, etc. is to create a model whose performance can be reliably measured on how it will perform in the real world, right? We don't just want to get a higher accuracy just for the sake of reporting it. We want to create models that work well in the real world, and that's why we do all these splits. So that's your training set now. The first 8 years of data, the first seven years of data, then validation set, the next 1 year of data, and then the next year and a half of data is the test set. Okay. If you do not have dates, then pick a random 60-20-20 sample. All right. And I'm just going to save my notebook once again and record another snapshot. Now, some of what we have done here may seem a little complex, it's not something that you may be able to grasp in the first glance, but do work through the notebook, or do go through every line of code. All of it is explained, and you can check out, you can separate out each line into a separate cell and try and work through it and see how it works out. So next best practice or next step in a machine learning problem is to identify the input and target columns. And often this is something that people tend to mess up as well, just in the hurry to get to the modeling process. So not all columns in a dataset are useful for training a model. In fact, in the current dataset, if we look at raw df, you can see here that we have a date column, and the date column is different for each day. In fact, it only contains dates from 2008 to 2017. Now, presumably we're going to use the model in 2020 or 2021 and onwards. So the date will never be something like this, right? So the model will, so there's no point training the model on these dates or dates which it has seen in the past if it is going to be used in the future, right? So date is not a useful input to the model. On the other hand, minimum temperature definitely is, because the model is going to see temperatures in the same ranges. It may not see 13.4, but it may see 13.5, it may see 13.1. So this is a useful thing to have. Maximum temperature is again a useful thing to have. So all of these rows, apart from date, like location, min temp, max temp, etc., these are definitely useful for prediction. So we definitely want to use these. Similarly, sometimes you will have ID columns. For example, in the last example of insurance or medical charges prediction, there were certain IDs. Sometimes you will have names of people, like you may have names of a customer, or maybe you may have emails of customers, or you may have like a customer ID or some unique identifier, which is different for every row. So whenever you have these ID columns, you should completely ignore those, because those are just unique and that is not useful information to use. Then there is obviously also a target column, the column that we want to predict. We want to take all of this information and we want to use it to predict the rain tomorrow column. So we want to make sure that we don't use the rain tomorrow column as an input for sure, right? You don't want to use whether it rained tomorrow to predict whether it rained tomorrow. You don't. The rain tomorrow is a target, and that is why, and it seems like an obvious thing, but in a lot of cases you will see that you are training a model and then you train the model and you suddenly see 100% accuracy, 100% training accuracy, 100% validation, 100% test accuracy. And you debug, or maybe you just think you've won, but ultimately you will figure out that you were actually using the target as an input. I do this all the time whenever I'm training models. So that's why one thing you should try and do is very clearly identify what are the inputs to your model and what are the outputs and what are the things you need to ignore.